Well, hello again. This is Dr. Bob Johnson. I am very excited to bring to our audience a very talented doctor, Dr. Nathan Bryan, who has done a mammoth amount of research on a topic that is going to be very important to all of you to understand a little better. I'm going to let him introduce it, but he not only is a wonderful presenter on this information, but the information he's going to present is very critical for everybody who wants to be healthy. So let me bring to you now Dr. Nathan Bryan. And good morning, Dr. Bryan.
Good morning, Dr. Johnson. Thanks for having me on. It's a pleasure.
Dr. Bryan is a professor at Baylor University, and he has his own company called Human N. He's going to talk a little bit more about that. He's written many papers and edited several books, but I was very excited when I heard him talk about nitric oxide. So without taking anything more from him, welcome again.
Thanks, Dr. Johnson.
So tell us a little bit about your background and how you got involved with nitric oxide research.
Well, I've spent my entire adult academic career studying the single molecule nitric oxide. I started off as a biochem major at the University of Texas at Austin, where I received a Bachelor of Science in Biochemistry, and then from there I went to LSU School of Medicine in Shreveport, and that's where I really got involved in nitric oxide research. This is about the year 2000, about 2 years after the Nobel Prize was awarded for the discovery of nitric oxide. So it was an exciting time to be in that type of research. We were fortunate to have Dr. Lou Ignaro come and speak before the student body at LSU School of Medicine, and he was one of the gentlemen who shared in the Nobel Prize. And so I had the opportunity to go to dinner with him that night and really just pick his brain on what is this nitric oxide molecule, why do we need to be concerned with it, and what's left to know about it. And his answer shocked me, and he said he was really surprised that a Nobel Prize had been awarded because there's so little that we knew about nitric oxide even in the year 2000. Number one, we didn't really know what went wrong in people that couldn't make nitric oxide, how to even detect it or diagnose it in certain patient populations. And perhaps most importantly, he said, we have no way to restore nitric oxide production in people that couldn't make nitric oxide. And so that got me excited, and so I basically delved into the whole nitric oxide field, and we developed some sensitive analytical methods that could actually detect nitric oxide. And then we were really armed with the tools that we could answer a lot of these unanswered questions. And so over the course of those, past 17, 18 years now, we understand what goes wrong in people that can't make nitric oxide. We know how to detect it in patients. And perhaps most importantly, we figured out how to restore nitric oxide production in people that can't make it.
Now, most people don't know about nitric oxide, so tell us a little bit more, kind of for the average person, what is nitric oxide and why is it so important?
Well, we now know that today there's probably over 145,000, maybe even 150,000 scientific papers on nitric oxide. It's one of the most studied molecules in medical history. It's recognized as probably the most important molecule that your body produces. And so it was recognized by the awarding of the Nobel Prize as a critical molecule in the cardiovascular system. So we now know that it's what we call a ubiquitous signaling molecule, or cell signaling molecule. It's how cells in our body communicate with one another. So nitric oxide that's produced by one cell goes and tells another cell to perform a specific function. And the best example of this is in the cardiovascular system and in the lining of the blood vessels. So when nitric oxide is produced in the lining of the blood vessels, it tells the smooth muscle cells that surround the blood vessel to dilate and relax. And when that happens, you get an increase in blood flow, you get an increase in oxygen and nutrient delivery to that tissue bed. And so it's how our body regulates perfusion and blood flow delivery to all organs and systems throughout the body. So you can imagine then if you lose the ability to make that nitric oxide, then cell signaling kind of shuts down, your body becomes confused and it doesn't perform as it was designed to do.
So it seems like even though we have our nervous system and our circulatory system, behind the scenes in our bodies, the nitric oxide is really doing the major part of the communication to tell one part of the body what the other part is doing.
That's correct, and it confused scientists for a number of years because this was a different signaling mechanism. So nitric oxide is a gas under normal atmospheric oxygen and pressure and temperature. And so this gas, which has a half-life of less than 1 second, so it's produced, it activates downstream targets, and then it's gone. And so that's been one of the major hurdles in the development of safe and effective nitric oxide therapeutics. How do you recapitulate the production of a molecule that has a half-life of less than 1 second? But we now know that it's a neurotransmitter in the central nervous system. It's produced by our immune cells and helps fight off invading pathogens, such as bacteria, viruses, fungi, any type of pathogen. And so there are a lot of things, when you lose the ability to make nitric oxide, there's a lot of things that go wrong in human health. It's not just related or unique to the cardiovascular system. People start to develop cognitive disorders when your neurons can't fire and make nitric oxide. Immune dysfunction starts to occur where you become susceptible to infections or you're not able to fight off infections. And then perhaps the most important manifestation of loss of the ability to make nitric oxide is you're more prone to cardiovascular disease, which is still the number one killer of men and women worldwide.
So what specifically would people look for if they thought they were, or how physicians would look and determine if someone is deficient in nitric oxide?
Yeah, that's a really fundamental question because we thought early on that probably they just developed high blood pressure and put them at risk for the onset and progression of vascular disease. But we now know that it's not just vascular related. So people start developing what we call vascular dementia. There's a reduced blood flow to certain regions of the brain, cognition declines, and it even precedes Alzheimer's or pre-Alzheimer's. Probably the first sign and symptom of nitric oxide deficiency is sexual dysfunction or erectile dysfunction. And that occurs in both men and women because in order for men or women to get an erection, you have to have an increase in blood flow, either to the penis or the clitoris, and that's what leads to arousal. And that increase in blood flow is caused by the production of nitric oxide. And if if the blood vessels and the ends of the nerves that innervate your sex organs can't make nitric oxide, then you can't get an increase in dilation and blood flow, and therefore you can't get an erection in men that's required for intercourse, and the women become anorgasmic because they can't increase the blood flow and the pressure in the clitoris of the sex organs, and so they become anorgasmic. So that precedes, I think, any increase in blood pressure, any other functional or structural changes in the lining of the blood vessels. Mm-hmm. So we also know that nitric oxide is critically important in regulating mitochondrial ATP production, which is the energy production organelles of the cell. So people become lethargic, they become tired, they become exercise intolerant, and they just can't do the things that they could do before because they have a decrease or inefficient energy production.
So the types of people who would be really benefit greatly by the nitric oxide would be, it seems to me, as people get older, as they start to develop health issues, but also athletes.
Well, that's exactly right. And here's I think, a critically important understanding that we have to begin to consider, because as we age, we lose the ability to make nitric oxide. In fact, the clinical studies demonstrate that we lose about 10 to 12% of our nitric oxide production capacity per decade. And this can start in the late teens, early 20s. So by the time we're 40 or 50 years old, in most people, we only have about 50% of the nitric oxide we had when we were younger. And it's also known that loss of nitric oxide is really one of the earliest events in the onset of progression. Most, if not all, age-related diseases. And so I think when we look at people who should consider nitric oxide, it's really everyone, because everyone's aging. And so we know that we can modify our diet and lifestyle to promote nitric oxide production. There's also diets and lifestyles that degrade or inhibit nitric oxide production. But what's clear from the literature is that whether you're sick or whether you're a well-trained athlete, that improving nitric oxide production is critically important because, as you mentioned, if you want to improve your athletic performance, then you've got to improve your nitric oxide production because your ability to generate nitric oxide actually predicts how well an athlete you are and how well you can perform. So it's not just well-trained athletes, it's executives, senior executives that want to improve their performance in the boardroom, it's people who want to improve their performance in the bedroom, or even athletes who want to improve their performance in the athletic field or in competition. Nitric oxide is really the foundation for those functional improvements.
And for, say, athletes, if they took a supplement or if they try to restore their nitric oxide, would this be something that's illegal for athletes?
Yes, it is. It's a natural, fundamental physiological response to exercise. And so in well-trained athletes that have good endothelial function, they can generate nitric oxide, improve blood flow to the working skeletal muscles, improve mitochondrial energy production, so ATP production becomes more efficient. In fact, you can make more cellular energy with less oxygen. And so these people can, in fact, that's the molecular basis of high-altitude training. It's not just an increase in erythropoietin and red blood cell density, but if you train at high altitude, you basically increase your nitric oxide output. And then when you come back down to sea level, you've got a competitive advantage because your body is adapted to a lower oxygen environment, so it's generating more nitric oxide. In fact, we have probably 170 or 80 professional and collegiate athletic programs that use our nitric oxide technology. We had the U.S. Olympic team using our nitric oxide technology in Rio for the Olympic Games. And so it's clean, it's all natural, and basically what we do is basically provide the body a source of nitric oxide and then basically improve the body's own ability to make it. And so this is a natural physiological response, natural way to improve performance.
So how does, it obviously exercise, but how does one truly restore, if they're deficient, how does one restore their nitric oxide levels so they get better performance?
Well, we understand now that there's basically two pathways to make nitric oxide in the human body. The first is through an enzyme that was discovered back in the 80s. It's an enzyme called nitric oxide synthase, and it's an enzyme that's found in our endothelial cells, the cells that line the blood vessels. It's found in neurons, and there's also an isoform that's found in macrophages and neutrophils in our white blood cells through our immune system. And so this enzyme actually converts arginine to nitric oxide, and it's the function of this enzyme that's really predictive of how well you can make nitric oxide. And so that's what we lose as we age, the function of this enzyme. The other pathway that was discovered just probably 15 years ago was through a dietary pathway. And this really explains the mechanism of action for the Mediterranean diet, the Japanese diet, a vegetarian diet, because vegetables that we eat, particularly green leafy vegetables or even beets, contain a molecule called inorganic nitrate. And so this nitrate is really enriched in green leafy vegetables. And so when we consume green leafy vegetables, our body takes this up through our gut, it absorbs it, and then puts it back in our salivary glands. And then about 90 minutes after we eat a salad or spinach or drink some beet juice, that nitrate, there are bacteria that live in the crypts of our tongue and in our mouth that reduce nitrate into nitrite and nitric oxide. And so this pathway depends on two things. Number one, the foods we eat, and it's getting enough nitrate in your diet. But then number two is the presence or absence of certain bacteria, because humans can't metabolize nitrate. We rely on the bacteria. The people who are overusing antibiotics or using anesthetic mouthwash that eradicate these oral bacteria, they're not going to get the benefit of the nitric oxide from the diet, from the inorganic nitrate. And we're finding that people who use anesthetic mouthwash and eradicate the good bacteria, that their steady-state blood pressure is actually higher. So this opens up an entirely new avenue for the management of high blood pressure. It's through the restoration of oral nitric oxide producing production, there are certain things you can do to improve the production through both pathways, and that's going to be probably the most optimal thing you can do in terms of prevention and preventing the loss of nitric oxide. So moderate physical exercise stimulates and activates this enzyme that makes nitric oxide. You need a certain redox environment, so food rich in antioxidants or even supplements that contain antioxidants can improve the function of this enzyme. And then from the dietary standpoint, we know that eating more green leafy vegetables and allowing the bacteria in the mouth to do the job and to keep these bacteria flourishing and feed them the substrates they need to respire, both of those can actually improve nitric oxide production. So at the end of the day, after 20, 30 years of research, it really comes back to what we've known all along. It's moderate physical exercise and a balanced diet that includes a lot of green leafy vegetables. Both of these tried and true measures increase and improve nitric oxide production.
And I know you have touted the value of beets. Just briefly talk about that.
Well, this came to light after the 2012 Olympic Games when it was realized that a lot of the Olympic athletes in London were drinking beetroot juice because in the published literature, it was demonstrated that drinking beetroot juice can lead to an increase in nitric oxide production, and it can lead to an improvement in performance in trained athletes. And so people, especially Olympic athletes or any competitive athletes, professional athletes, want to improve their performance to beat the competition. And now here's what we've found since, is that all beets aren't created equal. Depending upon where these beets are grown, how they're grown, the amount of sunlight, the soil conditions, the time of harvest, this whole field of agronomy basically determines and dictates the nutrient density of not just beets, but any vegetables for that matter. So we published a study several years ago showing that if we took 5 vegetables, and we took these vegetables from 5 U.S. cities, we went to Raleigh, New York, Chicago, Dallas, and Los Angeles, and we measured the nitrate content of these 5 vegetables in 5 different cities, and found that there was as much as a 50-fold difference in the nitrate content of these vegetables. So there's no standardization of this. So my point is that, yeah, beets are good for you. They contain a lot of important nutrients, but there's no standardization. So just going out and eating a couple of beets or drinking some beetroot juice isn't going to guarantee that you're going to see an improvement in nitric oxide production. In fact, there's several beetroot products on the market that we use as a placebo in our clinical trials because they contain no nitrate. They do not lead to an improvement in nitric oxide production, but it's a nice beet product. And so it actually is a very good placebo for us in putting our beet products to the test against any other product out there because we've standardized and in fact we've perfected this way of growing beets to optimize them for nitric oxide production.
I know that your company makes a nitric oxide supplement or lozenge, and also you have a little test strip that determines if a person is deficient or has sufficient amount of nitric oxide. Talk a little bit about those two things.
Yeah, so I had some discoveries back in the early to mid-2000s, and I submitted patents. I was then a professor of molecular medicine at the University of Texas Medical School in Houston. And as faculty there, when we had discoveries, we submitted initial disclosures, but then the university submits its patents. Well, those patents began to get issued because we had figured out a way to make nitric oxide in the human body. So that had enormous intellectual property value to the university. So I started this company back in 2009 to commercialize the discoveries and technology we had at the University of Texas Medical School in Houston. The one thing we realized coming out of the gates with the company was that, number one, most people didn't know what nitric oxide was, and they didn't know if they needed a nitric oxide product. And because there's no standard labs, you can't go to your physician and get a lipid panel and know what your cholesterol is or your vitamin D levels or your triglycerides. There's not a standard lab like that for nitric oxide. So we had to develop our kind of a test for nitric oxide. And so understanding this, what we call an enterosalivary pathway for nitric oxide, we were able to develop a salivary test strip. And so it's a non-invasive, semi-quantitative colorimetric test that you can apply some saliva to the end of the test strip. And within a matter of about 2 seconds, it'll tell you what your nitric oxide levels are. The darker the pink, the better the levels. And so you can actually monitor your own levels and see if diet and lifestyle can improve your nitric oxide, or taking some dietary supplements, or just simply changing your diet. So that was the genesis of the nitric oxide test strips, and also the genesis of the company. And now it's, I think, one of the most successful technologies ever developed at the University of Texas Medical School in Houston. But yeah, so we have this company called Human to the Power of N, and the purpose of this is to really bring to market state-of-the-art nitric oxide technologies. And because we want humans to be able to perform to their best ability, live to the power of N. And you can't do that without first correcting an inherent nitric oxide production system.
Very, very interesting, and you should certainly be applauded for bringing that technology of something that's so critical to people's health to the market. So good job.
You know, I think we've been able to do what big pharma and people have tried to do for the past 30 years, and that's to recapitulate nitric oxide-based signaling in humans in a safe and effective manner, that you're basically restoring normal nitric oxide production. And I've been fortunate to, work with the giants in the field. As I mentioned, had met Louis Naro early on, but when I was a fellow at Boston University Medical School in Boston, I was recruited by Fred Murad, was one of the other gentlemen who shared the Nobel Prize. And so that was really the foundation. So when I joined faculty at UT Medical School in Houston, Dr. Murad had a drug discovery system, and really that was the basis for what I was doing with screening natural products, screening a lot of herbs with medicinal properties, looking for small molecules or bioactivity that could either generate nitric oxide on their own or stimulate nitric oxide production. And so with these assays that we developed years earlier, we had the tools and the technology to really tell us and to optimize conditions that would do both. Provide a source of nitric oxide, so if your body can't make nitric oxide, then we have to do it for you. But then number two, perhaps the most important, is really getting to the root of the problem, understanding the underlying problem to the extent that we could restore the function of the nitric oxide synthase enzyme and actually lead to an improvement in people's own ability to make nitric oxide. So that's the basis for the technology. As you mentioned, we productized this through a company called Human to the Power of N.
And just so our audience knows, we can certainly get them that information and provide the products and the test strips to them. That's important.
Yeah, these have been on the market for about, we launched this technology in August of 2010, so about 6.5 years ago, so it's been commercially available.
I like the idea that people can literally now take control of their own health as opposed to relying on some medication or that kind of thing. So that's wonderful.
Well, I think obviously there's a change in healthcare, and I think it's obvious to me, and I think a lot of my clinical colleagues, that we have to move from a reactive practice to medicine to a proactive practice. And I think you hit the nail on the head, because patients and the general public have to be able to take control of their own health, not rely on the healthcare system. And here's what we know after 20 or 30 years of nitric oxide research, that your body can heal, and you can't be healthy without restoring nitric oxide production. And so we try to do a really good job of educating not just physicians and clinicians, but also the public and the general public and patients, so they can go to their physician and inquire about nitric oxide. And then we're finding that a lot of patients actually educate their physicians on the importance of nitric oxide, because it's still not what we call standard of care and a consideration for first-line treatment.
Tell us, or give our audience, the most important message on what you're trying to do and tell the public. Tell not only the public, but also practitioners who are listening to this.
Yeah, well, I have a very simple motivation and mission in life, and that's to educate as many people as I can on the importance of nitric oxide. Because there's basically three main things, or three themes that have evolved in the whole history of nitric oxide research. Number one, as I mentioned, it's the most important molecule that's produced within the human body. It regulates basically every biological function. And as we get older, we lose the ability to generate and produce this very chronic diseases, from cardiovascular disease, the number one killer of men and women worldwide, to Alzheimer's, the number 6 killer of men and women worldwide, and basically improves the performance of every organ, cell, and system in the body. And so, as I mentioned, your body cannot heal, and you cannot get healthy without first restoring the production of this ubiquitous self-signaling molecule, nitric oxide. And so it's really very simple, and I think we've been fortunate to figure out what goes wrong in people that can't make nitric oxide and then how to fix that fundamental problem. So that's been my mission, and that's why I really appreciate and feel honored to be with you, Dr. Johnson, to educate your listeners. And so any opportunity I get, or anybody who will listen, I tell the story of nitric oxide.
Good. Or if people want to learn more about not only your research, but nitric oxide in general, where would they go to learn more?
Well, they can certainly go to our website. We do a really good job of providing easily digestible material and published research on nitric oxide, and that's www.human.com. That's HUMANN, so human with 2 N's.com. You can Google my name, Dr. Nathan Bryan, and or go to PubMed or Medline and put in my name, and you'll find our published work, as well as that of many others. But I encourage people to do their own research, educate themselves, whether it's from our published work or from our website. There's a lot of misinformation out there, I should warn you. You can find anything you want on the internet. It's good, bad, or indifferent, and you just got to figure out what's valid information and what's not, because there's a lot of misinformation out there. But here's what I can tell you, is that anything we put on our website, it's published data, it's corroborated by peer-reviewed, published scientific reports or clinical trials. And so we try to do a good job of putting the right information out there and correctly educating and providing the right information.
Well, I think that our audience and anybody who will eventually listen to this can see how knowledgeable you are and how important this research that you're doing is. And so I want to thank you so much, and it will literally change many, many people's lives, as it already has mine. So I want to thank you very much for bringing this information out.
Thank you, Dr. Johnson. I certainly appreciate it. It's an honor to be with you this morning.
Have a great day. We'll talk to you later. Bye-bye.